Okay, I think we're up and running here. So let's get started. Let me do problem number 1 on the sheet. Let me get the sheet. All right, be right with you. Had to get a new Zoom going. All right, so the first problem, average rate of change of y equals square root of x from 0 to 4. So you make a table, do the square root of x, you go from 0 to 4, you take the square root of 0, it's 0, you take the square root of 4, it's 2. And what we have is a change in y of 2 units, y2 minus y1 is 2 minus 0, x2 minus x1 is 4 minus 0, and we compare those and we get a average rate of change of a half. Pictorially, this is what it looks like. 0 to 4, there's 4, that's a height of 2. There's 0, 0, right? First coordinate. There's your second coordinate, 4, 2. And the average rate of change is the slope of the secant line, and that is over 2 up 1, if I drew it better. Okay, so that is the slope, and that's the average rate of change from this location to this location on the graph, y equals x squared. So all you do is find the slope between the endpoints. Simple enough. Now, the mean value theorem for derivatives says that somewhere on this interval, we're going up at 1/2. And it looks like it's right about here somewhere. Right? So if I draw a tangent, which I'm not drawing very well, right? That's a little better. Tangent, that's also. And so we're going to try to find this value. Textbooks call that value C. It's an X value that we're looking for. This is generally referred to as A. This 4 is B. So C is an X value, just like A and B are X values. C is an X value. And the way we do that is we set the average rate of change, which we now know is 1/2. And we've been establishing the power rule. The power rule, another name for the square root of x is x to the 1/2. So in class today, and Antonio, you didn't get this kind of practice. The power rule basically says if you have a polynomial function, ax to the n, then its rate of change can be found by multiplying n times a, n, that's an n, it's terrible, n times a, and then dropping the exponent down 1. So we can do that here. We can multiply 1/2 times 1. Don't need to write the 1. 1/2 times 1 is 1/2. And that gives us x to the, take away 1, get you minus 1/2. So that's what we set this to. 1/2 x to the minus 1/2. I've asked you in class to memorize 1/2 x to the minus 1/2 as 1 over 2 times the square root of x, because that's the other way of writing this. Something to the 1/2, that means square root as a review. And this is in the denominator. So I'm putting the square root in the denominator to the first power. I don't have to write the 1. And we're setting that equal to 1/2. Well, I can cancel those 2's right now. So 1 equals 1 over the square root of x. Square root of x times 1 is the square root of x equals 1. So x equals plus or minus 1. We ignore the minus because it's not even in the domain. Okay, so this is the value 1, if I drew it well. That's where this function at an instant is going up at a 1-to-2 ratio. That was problem 1 and problem 2. And now I need problem 3, which is find an eraser. Boy, we don't have many, I'll say that. All right, I have an eraser. Not a good one, but I have an eraser. All righty, let's make sure my volume's on. All right, let's check this out. Let's hope that you heard me. Yes, the volume was on. All right, so now I'm going to erase this, and I'm going to do problem number 3. All right, problem number 3 coming up. Let me just write this over here real quick. R7, ROS, 7, I got to deal with that later. All right, so let me erase this and then look at problem number 3. So I'll do this quickly, this whole worksheet quickly. You can play it over several times. Those 2 questions will be on every test the rest of the year. And so you got to show me you know how to do it at some point. 3 left-hand rectangles under the square root of x from 0 to 4. All right, so we still, and I'm doing left hand, huh? All right, from 0 to 4. So here's 0, here's 4, and I wanted 3 left hand. 3 left hand. Did I want 3 left hand? Yes, I wish I didn't, but it's going to be hard to draw. So the altitude at 0 is 0, but we want to break this up into 3 equal parts. That's the best I can do. The first altitude is actually 0, so there is no height. The second altitude is that one, and the third altitude is that one. And so there are my left-hand rectangles, and that is not going to get used. That's going to get used. That's going to get used, and this one too, which is actually 0. So I got to find out the widths. I got a distance of 4 minus 0 divided by 3. Okay, so each of these is 4/3 units. So that's got to be 4/3 because I'm adding it to 0. That has to be 8/3 because I'm adding 4/3 to 4/3. And this is actually 12/3. Different way of writing the number 4, but I'm not using the right-hand side. I'm using these 3 altitudes. So the width is 4/3. And so 4/3 times the square root of 0 plus the square root of 4/3 plus the square root of 8/3 is all you have to write. Okay, now if I'm going to do trapezoids, there's the first one, which is actually a right triangle. There's the second one, which is a better approximation, still an under approximation. There's the third one. And in class, we said we do what? Trapezoids are the average. So you divide the width by 2 by the left and right altitudes. Okay, if you add up left and right and multiply times width, you'd have really a double-sized rectangle. You got to cut it in half in order to get that altitude. So we're going to cut this in half. We can make the numerator half the size, so 2/3 times the square root of 0. That's this one. This one gets used twice. Trapezoid 2 and trapezoid 1 share that altitude. So we want 2 of these 4/3. And then we want 2 of these as well, because that has an altitude. And that y value is the altitude. And y equals the square root of x. And that's the x I'm using. So it's plus 2 times the square root of 8/3. And the one at the end gets used once. Right? It's used, right? We're going up from here to here. So we're using that altitude. So that's one of these. Okay, so this is called the Riemann sum, and that's called the trapezoidal rule, and it's in your packet. And I guess I don't remember if I sent you a packet, Antonio. If I didn't, I'll send you one tomorrow. I'll upload it and send it. I got about 17 things to do between now and 7:30, trying to get to them. Write the equation line tangent to the sine function at x equals 3 pi over 4. All right, so I think you're the C block, which means that C block saw this, but you have it. So in your packet, you can find the derivative of the sine function. I'm not worried about you learning the derivative. What I'm worried about is your unit work. And I don't know how many of you know what the sine of 3 pi over 4 is in 5 seconds or less, but that's what you got to learn how to do. All right, so I am not going to do a review of trig right now. I am just going to draw the sine function and show you what the derivative is. So the sine function is actually going up at 1 to 1 right there. It's going up at 1 to 1. So the derivative, and this is the derivative of the sine function, we're going to find out what it is. That's how we can find maxes and mins, set the slope to 0. All right, so the slope is 0 at pi over 2. So pi over 2 gets us a 0. Slope is -1 here. I'm going decreasing, so -1. Back to 0, tangents. The tangent line gives us a visual feeling for whether something's going up or down at an instant. All right, it's flat there. If you zoomed in, really zoomed in, it would look flat for just that picture, but you can make that picture bigger and it would look like a straight line. All right, so we're back to -1 slope here. So that one was 0. That's the one I haven't put down yet. And then we're back to where we started from, repetition. And if I drew that well, that's a slope of 1. And so you get a curve that looks like this. And from your pre-cal class, you should recognize that. That's the cosine function. Okay, so we look at how do you write the equation of a tangent? Well, we're going to do 3 pi over 4. 3 pi over 4 is probably around halfway between here and here, right around there. So this is the line we're trying to draw write the equation for, that line. It has slope. What is the slope? The slope is the cosine of 3 pi over 4. Times what? Well, the x value we've been given is 3 pi over 4. And that's what we're building off of. So you would write x minus 3 pi over 4. Hopefully everybody knows why. Okay, and if you put 3 pi over 4 in, then we're supposed to know what the value is, the y value, and it comes from taking the sine of 3 pi over 4. Now, I'm happy to do unit circle work with you in math help, which is 7, which is where I am right now. It's only 6:40, but in 40 minutes, 50 minutes, excuse me, hopefully somebody's coming in, getting a little help, and maybe you need some help here. Maybe you don't know the cosine of 3 pi over 4 negative root 2 over 2. Maybe you don't know the sine of 3 pi over 4 is root 2 over 2. And if you don't, you ought to be coming in and learning that, because that's what you're supposed to bring into the class, that knowledge. If you don't have it, better find it. Not hard to do. It's not hard to come up with those. So now we're going to look at some quick integration and some quick differentiation according to the power rules. And so I have position, velocity, acceleration. Usually it's x of t, v of t, usually work with time, but we're going to work with the letter x. So we're going to have position, velocity, and acceleration, and I'll just write it that way for now. It might be something like f prime, f double prime. Okay, this is taking a derivative, and I'm starting with the ones in the middle, 5x squared, and let's see if you remember how to do this. All right, so if we're going in that direction, we are taking a derivative. What's the derivative of 5x squared? Hope you say 10x. All right, you do multiplication and drop it down 1. What did this? This is the derivative of what's over here, position, right? Velocity is how position changes on Route 91 for grandma. So what are you supposed to do with that? When you integrate 5x squared, what's the mechanics of that? Adding 1 to the exponent and then dividing it, and you're basically done. All right, so 5x to the 3rd over 3. The only thing that you also have to remember, 5x to the 3 over 3 is adding c. So if I took this derivative, it becomes that. If I took that derivative, it becomes that. And I do the inverse process left and right. Okay, so that's how you do that one. Next one was square root of 4th root of x to the 3rd. The 4th root of x to the 3rd. And I'm going to explain more fully what I'm doing and why as the term goes on. But there is no reason you can't memorize this now. All right, we talked about this. Don't know what to do with it. So you rewrite it as x to the 3/4. That is the same thing as this, as a calculation. That again is something you studied last term. So now, how do we take a derivative? Pause the video. Think it through. Oh yes, you multiply by 3/4 and you drop it down 1, which means 3/4, you're subtracting 4/4. And I get minus 1/4. Might be good for a review to make sure you know how to write this in a different fashion. So this is the same thing as 3 over 4 times the 4th root of 4. Just as a review from your last level of study. All right, so that's that one. Let me put it back up again. So what is this one? 3/4 x to the minus 1/4 power rule. How do I go in the other direction? What do I do to x to the 3/4? I add 1. Why don't I do 4/4? And then divide by that, which is 7/4. So I'll clean this up. 4/7 x to the 7/4 plus c. That's the position function for that term. We're going to do a lot more with it than this mechanical stuff. Don't worry. We're going to dive deep into what's going on. More so probably than anybody else. E to the x. What's the derivative of e to the x? All right. You can look in your pack, find it. You can look it up online. You can ask Google. It is e to the x. It is itself. That's why it's such an important exponential function. And it came from e to the x. I guess I got to write plus c again. All right. That's why it's so darn good, especially before computers and calculators. Because not only did you know if grandma was, her position was determined by this function, you also know how fast she's traveling at any instant. And you also know whether or not she's accelerating. Powerful function. That takes care of that. Quotient rule. Okay, quotient rule, which I don't think you have any chance of doing unless you look it up online. All right, and if you look it up online, you will see that there's a pattern, and the pattern we generally memorize as the following. low, and I'll do this tomorrow in class. D high minus high D low over low low. I'll show you the quotient rule real quick with x to the fifth over x squared, which is x to the third. And what's the derivative of x to the third? 3x squared. Okay, should be able to follow what I just said at this stage. All right, so I am going to do it, however, not by the power rule, but by the quotient rule. So I'm going to take my function, which is this, and I'm going to perform the little jingle. So low, first thing I'm going to do is take low. What's low? It's the denominator. So that's x squared. The derivative of high. What is the derivative of x to the fifth? I hope you say 5x to the fourth at this stage. Not you, Antonio, you haven't done it enough. Minus, I think you can put a minus sign there. High, what's high? X to the fifth. Times what? Derivative of low, d low. Okay, what's the derivative of x squared? 2x. Over low low, which is x squared times x squared. You can write it as x squared squared. Let's do the math. 4 and 2 is 6. 5x to the sixth minus 2x to the sixth divided by x to the fourth. All right, 5x to the sixth minus 2x to the sixth is actually 3x to the sixth. Yes. No. And x to the fourth, x to the sixth, I guess we get 3x squared from the quotient rule. You only have to do this part on tests. You only have to show that you know the quotient rule. We're giving you, don't put marker on the shirt. We're giving you credit for knowing how to do this algebra. And if you don't know how to do it, you're in the wrong class. All right. Let's see. So that's the quotient rule. And so that's the jingle. You can replay this, memorize it. I'll be doing it in class tomorrow. All right. Now we're looking at the limit as h goes to 0. And I'm going to be developing this a whole lot more than what I'm going to show you right now, but I'm under time pressure to get some things into the department, get some course changes made, get a homework made, and I have 40 minutes. So all I'm going to do is the mechanical. I'm not going to do anything else but the mechanical. But this is going to become an extremely important conceptual question that we will dive into a whole lot more. All right, I hope that's what I wrote over there. Yes. Okay. So I can't let it be 0 right now because you can't divide by 0. I'm going to do the numerator. Right? And I'm going to bring this down. I should rewrite it again, but for time, I'm not going to. So this is 36 plus 12h plus h squared. I hope you can learn how to do that quickly like that. Minus 36 all over h. All right, the 36 is canceled. I get 12h plus h squared over h. What can I do with that? I can write the addition as a product by taking out what's common, an algebra 1 skill. Okay, h times 12 plus h gives me the numerator. Dividing by h, what happens? The h is canceled. And now I get the limit as h goes to 0. I can let h go to 0, and I get an answer of 12. There's a whole lot more to this problem than I'm going to show you right now. That's just the mechanics. We'll deal with what's going on in class later. It's all about table values. All right, so that was your homework. I'm going to upload it now to my YouTube channel. And pause and get out of here. And there we go. Leave the